Assalamualaikum warahmatullahi wabarakatuh. So we'll present about our project. We are from group 3. We consists of 6 members. Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL FATIMAH BINTI HELMY with number matric DF200115, and I'll present for the introduction, objective, and also study area. So for introduction, we have 3 elements here, which is water reticulation, sewerage system, and also stormwater management. Okay, for water reticulation system are water distribution networks that require collection and treatment before being delivered to the consumers. And for sewerage system, so sewerage system is the network of pipe, pumping station, and accessories that transport sewage from its point to the origin to a treatment and disposal facility. Sorry. And for stormwater management entails stormwater outflow planning, analysis, and management. It also improves water quality in accordance with APA regulations. So for this objective of this project, there are 3. The first one is to determine the required water demand based on population size and design an elevated tank to meet the demand for an area near to Taman Wijaya and Taman Bukit Makmur. And the second one is to determine the size and sewerage for an area that is near to Taman Wijaya and Taman Bukit Makmur, Segamat Johor. And the last one is to determine the reproduction of surface water runoff in an area that near to Taman Wijaya and Taman Bukit Makmur. And for the last one of my part is study area. So as you can see from this slide, so the study area is like I said in the previous slide, near to Taman Wijaya and Taman Bukit Makmur, Segamat Johor. So this area is chosen because this area seems very strategic for development. So this area will consist of 48 units of terrace house, 20 units of bungalow house, and 32 units of semi-D house. Thank you. That's all from me.
Hi, my name is IKMAL, number matric DF200128, and now I will continue the presentation with the literature review. Water reticulation is the distribution of clean water to home and business in cities. It is essential for public health and sanitation. The sewerage system is responsible for collecting treating wastewater produced by buildings and houses to prevent the pollution and protecting people's health. Stormwater involves controlling, treating, and disposing precipitation to reduce the risk of flooding and protecting the environment. An integrated water management system combining all 3 components is important for efficient use of water resources and improving the quality of water. For the methodology, the purpose of water reticulation system is to transport water from a source to consumers. Therefore, this goal of this project is to determine the water demand based on the population in the proposed residential area and the size of elevated tank required to meet the need. For system sewerage, through the collection system and pipe, manhole drain, holding basins, catch basins, inlet, and pumping station, sewage can be moved from the collection site to the place where is it dumped. So this project goal is to plan the sewerage system and the size of the proposed residential area. For the stormwater management, to stop agricultural land from eroding and populated urban or rural from flooding, stormwater management is very crucial. Therefore, the goal of this study is to model the surface water runoff at the proposed residential area. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is ZHUO from ZAINY. My matrix number is F2040. I will present about the water calculation for this project. So based on this slide, you can see there is proposed area which is near to Taman Wijaya and Taman Bukit Makmur. From this area, we divided into 4 layouts. First is proposed pipe layout, second is pipe length layout, third is flow rate layout, and the last is schedule head layout. Next, in this slide, I will present about the calculation for population equivalent and water demand for this residential. In this slide, we can see there is layout for this residential. In this residential, there is three types of houses. First is bungalow houses, second is semi-detached houses, and the last is terrace houses. Population equivalent for bungalow houses is 100 population equivalent. Water demand for bungalow houses is 237,000 liter per day. For population equivalent for semi-detached houses is 160 population equivalent. Water demand for semi-detached houses is 281,200 liter per day. And for population equivalent for terrace houses is 240 population equivalent. And last is water demand for terrace houses is 326,400 liter per day. For commercial area, gross area for this residential is the total area is 5,501 meter square, and the total population equivalent for this residential is 665 population equivalent, and the key reservoir for this residential is 11,259,300 liter per day. So in this slide, I will present about the head loss and correction of flow pipe. For the head loss, we are using Hazen-Williams equation, and for the correction of flow pipe, we are using Hadri-Cross method. By using this equation and method, we can get the Q final until we do the calculation until the trial 5 by using the size and the type of material that we are assumed, and also the proposed elevation water tank that we are proposed, and also we are check the residual head is bigger than 7.6 meter, which is okay. So that's all for me. Thank you.
Good morning, my name is Imjala. Now I will present for the sewerage reticulations. So the diagram in this slide show the sewerage reticulation design plan. So all manhole to manhole with same distance, which is 35 meter, except for there are a few exceptions, which is manhole 4 to manhole 8 is 38 meter, manhole 8 to manhole 12 is 42 meter, manhole 12 to manhole 16 is 57 meter, manhole 16 to manhole 17 is 68 meter, manhole 21 to manhole 25 is 63 meter, and the last one, manhole 25 to manhole 29 is 59 meter. Okay, next. This diagram in this slide show the direction of each manhole to another manhole. So their final destination is to the sewerage treatment plant. Okay, next. For sewerage reticulation design in our project are using the new vitrified clear silver. So the silver diameter is 225 mm, which is 0.225 meter. The slope gradient is 1 to 150. The ground level is 25 meter. The initial depth D is equal to 1.2 meter, and the manning coefficient N is equal to 0.012. So the population equivalence that we obtain is 500. So using the table plant treatment capacity and PE of 500, then the STP is classified as class 1 because the PE is less than 1000. So use the table length requirement for class 1 and PE of 500, then the required area for STP development is 700 meters square. Okay, the average flow is 1.3 liter per second, and the peak flow factor is equal to 5.07. Peak flow is equal to average flow times peak flow factor. The value is 6.59 liter per second. So the conditions of the pipe is the full pipe flow, and the area obtained is 0.04 meter square. The wetted perimeter is 0.71 meter. The hydraulic radius is equal to 0.06 meter. So the velocity that we obtain is 1.045 meter per second, which is between the cleansing velocity 0.8 meter per second to 4 meter per second. So the flow rate is equal to 41.82 liter per second. The design flow rate is more than the required flow rate. So this design is successful and accepted. The diagram besides is show the distance, the length of silver from each manhole to another manhole, from the manhole 1 to the manhole 29. So, and it also show the flow, upper invert level, lower invert level, and also the depth. So that's all from me. Thank you.
Hi, my name is ZHUO. So now I want to present about part calculation for composite drain design. The objective is to determine the size of a composite drain to convey a 10-year ARI minor system design flow from a proposed 10-hectare residential development in Segamat. The post-development time of concentration (TC) at the development outlet is estimated 50 minutes. So for the first step, it is to determine the rainfall intensity by using formula I equals to lambda Tk, lambda T power of k divided by T plus theta power of n. So we'll get a value 117.52 millimeter per hour. The second step is to determine the peak flow by using formula Q equals to CIA divided by 360, and we will get a value 2.12 meter cube per second. The third step is to determine the dry weather base flow and minor flows up to the 10 millimeter rainfall depth. So the crude dry weather will get a value of 0.36 meter cube per second. So the fourth step is to calculate size of line drain section. So we assume magnitude M for concrete lining is 0.015, and assuming drain longitudinal slope is 0.5%, drain width is 0.6 meter, and side slope is 0. By using try and error method and using the equation given below, and we can get the final Q is 0.467 meter cube over second, which is larger than 0.36 meter cube per second. Well, for the last step is to calculate size of total drain section. We assume magnitude N for concrete lining is 0.015 and magnitude N for stone pitching is 0.035. And same, we use try and error method and using the formula, so we can find the final Q total is 2.257 meter cube per second, which is larger than 2.12 meter cube per second. So finally, we provide dimension of composite drain. Top width is 4.6 meter, bottom width is 0.6 meter, depth is 0.5 meter, and the discharge Q is 2.257 meter cube per second. That's all for me. Thank you.
Hello, my name is Cherry Jing, and now I'm going to continue present about the part discussion and conclusion. So our planning area is located in Segamat, and there will be three different types of buildings that are single-story terrace, semi-detached house, and double-story bungalow in this project. So for this building, we have designed water reticulation system, sewage system, and then drainage system for this 10-hectare residential area. So for the water reticulation system, after we calculate the population demand, the total water demand for the residential area is 844,600 liters per day. So the proposed water tank size is 35 m in breadth, 10 m in depth, and 70 m in height. Through HADI cross method calculation, the proposed diameter of the pipe size is 0.25 meter and the pipe material used is unplasticized polyvinyl chloride, which is UPVC. So for the sewage system, the population equivalent we calculated is 500 population equivalent, which equivalent to the class 1. So the land area required for our sewage system is 700 meters square. The design flow is greater than the required flow rate in the sewage system. For the drainage system, the composite drain used in design is 10 years ARI minor system. So the design flow for the composite drain is 2.12 meter cube per second for the peak flow. So the composite drain is built up by two materials that include concrete and stone. The proposed dimension has been explained earlier, and the design flow rate is greater than the required flow rate. So that's all from us. Thank you.